Hello guys, welcome to the second video of machine learning. Today we will talk about end-to-end machine learning project using regression and classification problems. So in today's video, we will go through an example project end-to-end, and here are the main steps we will follow. First, we look at the big picture, and then we get the data. We discover and visualize the data to gain insights. We prepare the data for machine learning algorithms, and we select a model and train it. We fine-tune the model, present the solution, and lastly, launch, monitor, and maintain the system. So here are some of the popular open data repositories. Usually we will get data from UCI, Kaggle, and AWS datasets. Usually for students or beginners or just basically anyone who's interested in data science and needs some dummy data, we will usually go Kaggle or UCI to get data. So today we chose the California housing prices dataset from the UCI repository. This dataset was based on data from the 1990 California census. It is not exactly recent. You could still afford a nice house in the Bay Area at that time, but it has many qualities for learning, so we will pretend that this data is a recent data. The first thing we need to do is to pull out our machine learning project checklist. And the first checklist is to look at the big picture. So the first question to ask your boss is, what exactly is the business objective? Building a model is probably not the end goal. How does the company expect to use and benefit from this model? This is important because it will determine how you frame the problem, what your algorithms are, and what performance measure you will use to evaluate your model, and also how much effort you should spend tweaking it. So your boss tells you that your model's output will be fed to another machine learning system to determine whether it is worth investing in an area or district or not. And our model will be the blue color part where we output the housing price for investment analysis. So basically, we get the district data and we build a model to predict the housing prices in California. And then our model output, basically the predicted housing prices, will be fed into another machine algorithm, which is investment analysis, to determine whether or not this is a good investment. So now that we know the business objective, and with all this information, we should be able to start designing our system. First, we need to frame the problem. Is it supervised, unsupervised, or reinforcement learning? So from last video, we learned what is supervised, unsupervised, and reinforcement learning. So is it a classification task, a regression task, or something else? Should you use batch learning or online learning techniques? Now, it is clearly a typical supervised learning task since you are given labeled training examples. The district median housing price is our labeled data. Moreover, it is also a typical regression task because we are asked to predict a value. The housing price is a value, so it is a regression task. This is a multiple regression problem since the system will use multiple features to make a prediction of the housing price. It is also a univariate regression problem since we are only trying to predict one single value for each district. If we were trying to predict multiple values per district, it would be a multivariate regression problem. Finally, there is no continuous flow of data coming in the system. There's no particular need to adjust to changing data rapidly, and the data is small enough to fit in memory, so plain batch learning should do just fine. Now, our next step is to select a performance measure. A typical performance measure for regression problems is root mean square error, RMSE. It gives an idea of how much error the system typically makes in its prediction, with a higher weight for large errors. That means root mean square error is very sensitive to outliers. As such, when there are many outliers, you may want to consider using the mean absolute error (MAE). However, root mean square error performs very well when outliers are rare, hence it is generally a preferred method. Great! Now that we know what to do, we are all set, the lights are green, and we can now start coding. Now, first we will need to have Python installed in your computer. Well, if it's not installed yet, please get it at this link, python.org. Alright, so let's open a terminal and type the following commands. Export ML path equals to home/ml. So now we are creating a path called ML path, and it goes into your basically your user/my name is Jamin, user/Jamin, and it creates a ML folder inside of that. Now we are creating mkdir. Let's create folder in ML path. Okay, now it's done. Now we have ML folder inside. Next, let's check to see if pip is installed in our computer. Python 3 and pip version. Okay, yes, I have pip 23.0.1 installed, but you should make sure you have a recent version of pip installed. And to upgrade the pip module, just type Python 3 and pip install user u pip, and yes, you've successfully upgraded and installed pip. Now next, let's create an isolated environment. If you would like to work in an isolated environment, which is strongly recommended so you can work on different projects without having conflicting library versions, install virtual environment by running the following pip command. Python 3 and pip install user u virtual environment. Okay, done. Now we have virtual environment installed. Let's cd and go into our ML path that we've created previously. So now let's type in source env/bin/activate. Okay, now we are in our virtual environment. We can install all the required modules and their dependencies using this simple pip command, which is Python 3 and pip install u Jupyter. We need matplotlib, numpy, pandas, scipy, scikit learn. Yep, enter. Now we are downloading all these libraries and modules that we'll need. Okay, now the downloading process is done. To check your installation, try to import every module like this. Python 3 c import Jupyter, matplotlib, numpy, pandas, scipy, scikit learn. There should be no output and no error. So now you can fire up Jupyter by typing Jupyter notebook. Okay, and you should see this pop up. A Jupyter server is now running in our terminal, listening to port 8888. Now create a new Python notebook by clicking the new button and selecting the appropriate Python version, Python 3. This does three things. First, it creates a new notebook file called untitled.ipynb in your workspace. Second, it starts a Jupyter Python kernel to run this notebook. And third, it opens this notebook in a new tab. You should start by renaming this notebook to housing. And this will automatically rename the file to housing.ipynb. Now this notebook contains a list of cells. Each cell can contain executable code or formatted text. Right now the notebook contains only empty code cell, one empty code cell labeled in 1 here. Try typing print hello world and click on the play button or press Shift Enter. and you'll see hello world. This sends the current cell to this notebook's Python kernel, which runs it and returns the output. This result is displayed below the cell, and since we reached the end of the notebook, a new cell is automatically created. So this is a very important GitHub link that you should write it down somewhere in your notes, because it basically contains all the contents and all the codes we need for all our machine learning videos. Please come to this link and go to the code and download zip to download all the files in this GitHub repository. And once you've done downloading, open up your Jupyter notebook and click on 02 End-to-End Machine Learning Project, and you'll see this. So this is basically the end-to-end machine learning project with complete code. Please play around with this Jupyter notebook and use the machine learning checklist that we learned earlier, from looking at the big picture to eventually training and launching the model. So all the codes will be available here, from setting up, getting the data, visualizing the data cleaning, handling the tags and categorical variable, fine-tuning a model, and eventually training and evaluating your model. So please go into this Jupyter notebook and play around with the codes so you know what an end-to-end machine learning project is. Thank you so much for listening, and I'll see you in the next video.